So in the previous video, I was working on finding the derivative dy dx of this expression using implicit differentiation. And I guess the video got cut off at the end of working this problem. So I want to go ahead and finish this out. So we'll just take this from the very beginning and work it out. Again, our plan is to find, our goal is to find dy dx, which means we need to differentiate implicitly with respect to x, and then solve for dy dx. So what do we have here? We have two terms on the left. This term is going to require the power rule. There is no y in this term. This term does have y. This is going to require the product rule. I'm going to put the negative with the sign and not with the tangent. And then the right-hand side is going to require the chain rule because this is cosine of a function. And so we have we have power rule, we have product rule, and we have chain rule in this problem. And then we're going to need to solve for dy dx. So let's see if we can finish this out here. Derivative here is 2x. And then we have product rule. So I'm going to say first times derivative of the second plus the second times the derivative of the first, and that's going to equal the derivative here, and we'll worry about that here in just a little bit. So I need first copy paste. Remember, the negative goes with the value behind it. So copy paste negative sine of x. Everything here is multiply. So this is 2x times negative, right? So it's first times derivative of the second. The derivative of tangent of something is secant squared of that something, but then we need dy dx. All right, so first times derivative of the second plus the second, copy paste, times derivative of the first. So that's negative cosine of x. First times derivative of the second plus second times derivative of the first. And so then the last piece is we need to find the derivative here using chain rule. The derivative of cosine of something is negative sine of that something times the derivative of that expression, which in this case is 8x. All right, so that is a great big mess. Let's see if we can clean all this up a little bit. This term includes dy dx. This parenthesis is in the wrong place. This parenthesis should be here. And so let's see. Let's put all this together. This is negative 2x sine of x secant squared of y times dy dx. And then this is minus cosine of x tangent of y is equal to, let's combine all this, negative 8x sine of 4x squared. All right, so we have one term with dy dx. We have a term without dy dx and a term without dy dx. And so any term that does not have dy dx has got to move to the right-hand side. So this piece needs to go to the right-hand side of the equation. This stays where it is. That stays where it is. So let's reshuffle this. So we have negative 2x sine of x secant squared of y dy dx is equal to, this was already over here to start with, and then this needs to get moved over to the other side and become positive, plus cosine of x tangent of, this should be a y. I copied that incorrectly. Y. Good, this is a mess. But we're finally getting there. It's this expression times dy dx is equal to this big long expression. So divide both sides of the equation by that bit. This is easily more than, this is beyond what I would ask of you exam day. But for the record, there it is. This is homework. You have access to the universe here, or this is an example here. So you can watch this whatever you need to. So dy dx is equal to, all this is the numerator, plus cosine of x, tangent of y, all great big over all of this. All of this. So that's negative 2x sine of x secant squared of y. And that's all there is. So that was that problem worked out the rest of the way. And I will just list this video after the preceding video where this got cut off. Again, this is just a wild, crazy example with, we have power rule, we have product rule with dy dx, and then we have chain rule here, and then just a boatload of algebra to try to solve for dy dx.